Hey class, welcome to the slides and lessons for 7.1 Adding and Subtracting Polynomials. It's our first lesson in Chapter 7. So the first thing that you're going to have for a warm-up is that you're going to actually say what the difference are between these different expressions. So obviously our first expression here, we have x squared plus 2x plus 3. Then we have 4x plus 5, then 3x, and then 6. So what's the difference of each one of these? Like what's something unique about each one? You will put that in on Canvas. Here are the learning targets for today. Please make sure that you write down all three of them. The first one is finding the degrees of monomials, then it's classifying polynomials, and then it's adding and subtracting polynomials. All right, our first thing in notes here, it's a fair amount to write down, but you will want to write down these keywords as well as these tables. And there are quick reasons. So we're going to talk through them here in just a second. So monomial is a number or a variable, and it's the product of a number and one or more variables with a whole number exponents. So you got to have whole number exponents, can't have negative exponents or fractional exponents. So these are all examples of monomials because they are singular pieces. They might be multiplied together like 3 times x, but they're not divided. And they're not added or subtracted. They're just monomials, so they're one-part things. So each of these is an example of a monomial because it's one piece of a polynomial. The degree is the sum of all exponents of all variables. If there are no variables, then the degree is just 0. So as we're looking at these ones, this first one, the degree is 0 because it doesn't have a variable. This one has a variable of x with technically a 1 next to it because there's just a singular x, so that's why the degree is 1. Here, it's 1 plus 2 is equal to 3 because there's 1 for the a and 2 for the b. And then on our last one, it's m to the 5th, so that's where our degree is to the 5th power here. These ones are all examples of knots. So we're going to look at these ones. We want to find the degrees and how much of each one it is. So for our first one here, the degree is equal to 2 because it is a second degree polynomial because it's x squared. Our next one, our degree, it's the 4th degree because it's x to the 1st and y to the 3rd. So again, we have a 1 plus 3 is equal to 4. This one here is a 6 because we have a x to the 3rd and x to the 3rd, which would be a total of 6 of them. And then lastly, there is no variables, so our last one is just 0. This is where the notes that are probably the most important, and this is, again, as we move throughout this year, this is probably the most complex stuff we've seen so far, so make sure you're writing down all these things. So a polynomial is a monomial or a sum of monomials. So poly can mean one or more than one. So we have a couple special names for ones that are two-term ones. We call them binomial because bi means two. So binomial has two things that are being added together. It's two monomials added together to make one expression. Likewise, a trinomial is 3 things added together that make one expression. You could have subtractions in there too, that's okay as well. The degree of polynomials is the greatest degree of the terms. So you have to look at all the terms. It's helpful if you have them in standard form, which means they go in order. So it goes the highest exponent, and then the next exponent followed up by the constant term. When we talk about things like the leading coefficient, it just means whichever one has the highest degree, we look at that coefficient, the number that's being multiplied by the variable. So we'll want to write this in standard form. Again, remember that standard form is decreasing degrees. So we'll want to write our first degree here. We see that we have 15x to the 1st minus x to the 3rd plus 3. So when we rewrite this in standard form, we would get negative x to the 3rd minus 15x plus 3. So our degree here is equal to 3, and our leading coefficient, which to save some time, I'm just going to say LC, which is going to be at my leading coefficient. that is going to be equal to -1 because I have a -1 times the x value there. Notice both of these things I'm getting from the very first number in my standard form, so decreasing degrees, so it goes the largest degree, then the next largest, and then the one with no degrees. For each of these, I want you to classify it, make the standard form first, figure out what the total degree is, and then what type of polynomial is this. Take a little bit of time, pause this video, try to do this one first on your own. Do not just wait for the answers in the video, but actually try it on your own. So here we've listed each of the polynomials from A, B, and C. We've written them in standard form, meaning we put them in the highest exponent first, followed by descending exponents. Notice here how this first one only had one exponent, so that's just the only piece to it. The next one had x squared and then x, so we're going to put those in order. And this one had q to the fifth and then a singular q, so put those in order. The degree here is 4 because the exponent is 4. The degree here is 2 because the first exponent is 2. The degree here is 5 because the first exponent is 5. And again, this is a monomial. It's a one-part thing. A trinomial, this has 3 parts to it. This is a binomial because it has 2 parts to it. All right, adding and subtracting polynomials. The big things you need to know out of here is the fact that anytime you get a difference or a sum, it's going to be another polynomial. To add in them, you add like terms. So again, adding like terms is something we've done this year already, so it's going to be very similar to what we've done. This first example has some where we are finding adding like terms. So if we look here, and if I take my little highlighter, I'm going to highlight things that have the same term. So this one here has 2x to the third and a positive x to the third. That's going to be, I'm going to mark that with one color. Then I'm going to mark my next one, x squared, with a new color. And finally, I can mark my x's in a third color, followed up by a fourth color for my constants. So as I look at this one, I'm going to get 2x to the third plus x to the third. So that's 2 of them plus 1 of them. That's going to leave me with 3x to the third. Then I'm going to look at my x squareds because that's my next thing in order. So I have negative 5x squared and positive 2x squared. Well, negative 5 and positive 2 simply make negative 3x squared. I have a singular x and a singular negative 1, so those are just going to come down as is. So plus x and minus 1. Again, I would encourage you marking up your problems to figure out which ones are the same like terms, and then you're using the operation between them to help solve. Let's look at another one. So this next one has x squared and x squared. Then it has an x and a positive 4x. And a negative 6 and a positive 10. Notice this one did not have anything to the third, so we're only going to have the 3 powers here. So 3x squared plus 1x squared would be 4x squared. X squared and 4x is going to be 5x. And then negative 6 and 10 is going to be positive 4. Not too hard. Identify your like terms and then just put them together with the rules provided. Subtracting is very similar, except you just need to remember that you're subtracting. So whatever comes first, you're doing this minus this next thing, this minus the next thing. So again, I'm going to do the same thing. I'm going to identify my like terms by doing some color highlighting. Doesn't matter what colors you use. I'm just grabbing the 3 ones I can grab first. So here I have 4n squared minus negative 2n squared. So 4 minus negative 2, this would be positive 6n squared, because minus a negative is turning it into a positive. Then my next one in order would be my n's. So this is minus 2n, meaning I'm going to be left with a negative 2n here. Notice how my sign changed for that 2n. Lastly, I have 5 minus negative 4. This becomes positive 9. As we look at our last example, again, this last example has just squared, so I can start with my squareds on this one. Highlight my x values, and similarly highlight my constants. So 4x squared minus, remember there's a minus in between here, so 4x squared minus 3x squared is just going to leave me with x squared for this one. Negative 3x minus negative x, so negative negative is going to make this a positive over here, so it's really negative 3x plus x. So then we're going to be left with negative 2x, because if you have negative 3, we're going to add the x to that negative 3x. Lastly, we have positive 5 minus negative 8, so minus negative here is plus, so 5 plus 8 is going to become plus 13. There's a quick word problem here. This gives you two different rates. The first thing they ask you to do is find the difference between them, so you just are just subtracting these. When you subtract these three, you're left with negative 40t plus 100. Then it says figure out what that means. Well, initially, if you plug in 0, there's a difference of 100 here. But then every time it increases by 1, because t is times negative 40, we're going to get closer by a rate of 40 feet each second. You have homework on big ideas. Good luck and get to it.